we're going to be looking at solving radical equations. With this, radical equations mean that you have, like a square root or a cube root, something of that nature, in which you are going to have to solve for your variable. We'll start a little bit basic here, and then we'll get into a little bit more challenging of problems, but there's a general form or general steps that we use in order to solve our radicals. Step one is to isolate the radical term. Step two, square both sides to remove the radical. Step three, solve the equation. Depending on, how to solve the equation, it adds another dimension here. And step four, eliminate any extraneous solutions. Again, this is in general terms. So, every situation is going to look a little bit differently, but in general, you can isolate the radical term. You can square both sides to remove the radical. It just might be that some equations require a little bit more in order to complete step three of solve the equation. Okay, it just kind of depends on what your equation looks like to start with. So let's start a little bit basic right now. So let's say that I have the square root of 5x plus 1 equals 6. Okay, so step one was to isolate the radical term, meaning you need just the radical on one side. And looking at our situation here, we already have that. So step one, check. Step two, square both sides to eliminate the radical. Okay. So I'm squaring both sides to eliminate my radical. When I do that, the square root and the square cancel each other out. So I'm left with 5x plus 1 equals 36. Okay, check two, or step two, check. Step three, solve the equation. This is just a regular algebra problem, so not that challenging. Move the 1 over and then divide by 5. Check. Step four, check to make sure that you're eliminating your extraneous solutions. So remember, underneath, in this case, since we have a square root, we cannot have a negative number. So if I have the square root of 5 times 7 plus 1, is this possible? Check. So since it is possible, we can then say that x equals 7. We just verified that and not a big deal. Now, it gets a little bit more difficult when our equation has a little bit more depth to it. Okay, let's have x minus 6 equals the square root of 3x. Isolate the radical on one side. Check. Square both sides. Now, this is where it gets a little bit more tricky on this part. This x minus 6 is technically listed twice. When it's listed twice like this, we actually have to distribute this. A lot of people will just look at that and say, oh, it's x squared plus 36. But you got to remember that there's distribution involved and there is a middle term here. This is x squared minus 6x minus 6x plus 36 equals that right side of 3x. So, got rid of my radical. Now I'm going to have to solve this and move everything over to one side. Because the x squared on the left is already positive, I'm going to leave it there and then work with that. So I have now negative 15x plus 36 equals 0. Well, looking at this, solve the equation. Well, before it was a little bit easier. It wasn't an x squared. So we could just run through that algebraically really fast. Well, here you have an x squared. So you're going to have to AC factor or use the quadratic formula. So solving the equation, like I said, could involve a little bit more challenging of steps. It just depends on what your equation, how your equation starts. So if I'm going to factor this is not that big of a deal. My AC, in my case, I'm looking for the factors of 36. 1 and 36, 2 and 18, 3 and 12. I'm looking for that negative 15, so I already found it. So I'm not going to finish listing out my factors. Because it's a negative, again, I'm going to run through this quick. X minus 3, x minus 12 equals 0. Set each one of these factors equal to 0. Solve for x. And I am going to now check for extraneous solutions. So again, I have to go back up to the very beginning and substitute in my x values to make sure that it's even possible, because I can't have that negative square root. So that with the 3 does work, as well as with the 12. Oh, and you got to make sure that, I guess, sorry, I shouldn't just, that's the only thing you're looking for. You also have to double check to make sure that each side does equal each other. So looking at this, we do kind of have a little bit of an issue here on the left. If you notice here, one of these is positive and one of these is negative. Here's the thing. Even though yes, when you take a square root, it's a negative, you can get a negative. This is not the same. So they're assuming that when you take the square root, you're going to get the positive number. So these are not the same, which is going to result in that x equals 3 to not work. Since the right side, it does equal a positive 6 and a positive 6, our only actually answer is x equals 12. So when you're checking for the extraneous solutions, technically, yes, it does need to be plugged into both sides or both x variables from the very beginning to make sure that they equal each other on both ends, because you could end up with a negative and a positive, such as the case here. Last but not least, I have one more example. I know I'm getting lengthy here, but I want to do one that has square roots on both sides. It's actually easier than what you think, so this shouldn't take too long. Okay, so I know it said to isolate, step 1 said to isolate your radical on both, or on one side. But here's the thing, since it's a square root with nothing else attached to it on both sides, you can go ahead and square it. When you do that, the squares cancel out the square root, so you're left with 4x plus 1 equals x plus 10. Well, now this is just an old algebra problem that we can do no problem. 3x plus 1 equals 10, 3x equals 9, x equals 3. So again, double check both sides to make sure that they in fact work. Do I get the same thing? Over here on the left, I would get the square root of 13. On the right, I get the square root of 13 as well. So it does work out, x equals 3. So if you follow those steps, it's just generalization, but that's kind of the goal, is to get, isolate the radical on one side, square both sides, solve the equation, and then check for extraneous solutions.